Way back, we learned how to graph linear systems of equations. For instance, y equals, I brought back the laser, y equals 2x minus 3 and y equals x plus 5. Of course, to graph this top equation, I'll go to 0, negative 3 and put a point, go up 2 to the right 1, and then draw my line. For the second equation, I go to 0, 5, go up 1, over 1, and then draw my line. And you can see, or it's maybe you can't see, but these two lines intersect at the point 8, 13. We also learned that we could solve this system of equations using substitution. So I substituted 2x minus 3 in for y right there. So I have 2x minus 3 equals x plus 5. If I subtract x and add 3 to both sides, I get x equals 8. I then take that solution, plug it back into either one of the two original equations. I plugged it into the bottom one. 8 plus 5 is 13, so my solution using substitution is 8, 13. Well, the same thing works if it is a nonlinear system of equations. Here is a nonlinear system of equations. Yes, that's a line there, but that's a parabola. So this is a nonlinear system of equations. We do the same thing. Right? Y equals x squared plus 2. You'll graph as I've shown you, finding the vertex, finding 2 points on either side. In this case, it was the parent function raised by 2, so I graph that using my 5 points. And then I graph the line, well, y equals negative x plus 8. I went to 0, 8, put a point, went down 1, right 1, and drew my line. And you can see here that these two figures, the parabola and the line, intersect at 2 points, 2, 6, and negative 3, 11. So I have two solutions to my system of nonlinear equations. I can also do this using substitution, and you will too. So I'm going to take x squared plus 2 and plug it in for y right here. I then add x and subtract 6 from both sides to get x squared plus x minus 6 equals 0. I factor that, and you can factor it. You can use the quadratic formula. Factoring looked pretty easy, so I factored it. X plus 3 times x minus 2 means my two solutions are negative 3 and 2. So I took each of those, the negative 3 and the 2, and I plugged them into this top equation. I got 11 and 6, and so my two solutions using substitution are negative 3, 11 and 2, 6, and lo and behold, they are the same. Make sure you fill out your whisk.